Welcome back to our chapter on straight line graphs. In this section we're going to look at a word that we've been using in the last couple of videos called gradient. We're going to look at what is it and how can we measure it. So first of all, gradient. When we look at gradient, we are measuring the steepness of a slope. Now normally we would think of things like roads or paths or ramps, and therefore the larger the gradient, the steeper the slope and the more difficult it is to climb. In this area though, we're going to be looking at straight lines, and we're going to be looking at the gradient as a measure of the slope. So you may recall, if you were listening to the Tour of France earlier on this year, that some of the commentators, when they're talking about sections of the road, would be saying things along the lines of it's an 8% gradient or a 10% gradient, and that was to give us a bit of an indication of how steep the road was and therefore how difficult the climb was for the riders. Well, that's what we're going to look at. We're going to come up with a measure, and we need to come up with some numbers in order to calculate that measure. Well, first thing we want to do is to work out whether it's a positive or a negative gradient. In this graph here, I have a line that is heading up to the top right hand corner. So if it heads up in the top right hand corner, we say that it has a positive gradient. So whenever we look at the coefficient that was in front of the x, it's going to be a positive number. In this example, the line is heading up towards the left hand side. So the left hand side, just drawing it here, the left hand side is said to be negative. You don't need to copy this down just at the moment, I'll give you a summary at the end. So the easiest way to think of this is these numbers along the x-axis are positive, these numbers on the left hand side are negative. But what about if a line goes straight across the page? So when we would consider, say, a path or a road, you would say that it had no steepness, it was flat. And so it's very similar. In this case we say that the gradient is 0. It has a 0 gradient. Not very steep at all. Well, a line that goes straight up and down the page is so steep that we can't actually give it a measure in the current format that we are using. So we just say that it is undefined. It's a fancy way for saying we just can't measure it. So here's a summary that you need to copy down. So pause the video now, copy down these 4 little sketches, and you can see that the top left hand corner up towards the right is positive. So I'll just put that in for you. Up towards the right, positive. Up towards the left, negative. Straight across the page, 0. And then straight up the page, undefined. So copy that down now. Alright, well, often we want to actually give a calculation of the gradient, so that's the measure part, and we need, as I said earlier, 2 numbers to do that. Those 2 numbers are what we call the rise and the run. So there are a series of steps that we can follow to find the rise, the run, and then calculate the gradient. The first step is that we need to know 2 points on the line. If I can find 2 points on the line, I draw myself a right angle triangle that has the hypotenuse between the 2 points. Then I actually count from one point to the next how far across and how far up I need to go. So the rise is how far up and the run is how far across. And then you need to work out from the exercise we just did whether it's positive or negative, and finally you write the gradient as a fraction and you simplify where possible. So just copy this down for a moment and then I'll show you a little example. Alright, here's the example I'm going to show you. Here we have a line, and I've already identified 2 points on the line, so I could in fact identify any 2 spots. There's another one down here. The idea is we need to make sure that where we identify the points that we know exactly where they are. So I can't go halfway along because I can't be exactly sure whether I'm halfway or not. So I try and get on the intersection of the grid lines. Now what I need to do is I need to start at one point, but we usually start at the bottom left hand corner, and I need to be able to count across how many steps it would be. So in this case I'd go 1, 2, 3, 4 steps across. That's my run, and then my rise would be 1, 2, 3, 4 up. So let's have a little look how that would show on the gradient. So my rise, the blue line, is the 4. My run going across the x-axis is also a 4. It is positive because it is heading up towards the positive side. So therefore my answer is positive 4 over 4, the answer being 1. Now we don't normally show the positive sign, so we don't need to put that in, but we do need to simplify it. So now I'm going to try another example. Let me just move this to another point. Once again, starting at one point, counting across, that would be 8 steps across. Counting up, that should be 4 steps up. Let's just check that. So my rise is 4, my run is 8, so my gradient is 4 over 8. And once again, going up in the positive direction, it's positive 4 over 8. I would simplify that to positive 1/2, but you can have it as a decimal. Let's try one more. This time I'm going to slope it slightly different. Might make it just a little bit steeper. So in this case, I've changed the angle of the graph. It is heading up towards the negative side, so it's going to have a negative gradient. My rise, if I start at this point, my rise would still be 1, 2, 3, 4, 5, 6, and my run would be 1, 2, 3. Now I don't need to worry too much about whether it's positive 6 and negative 3. I just need to count for the moment. So my rise, from one point to the other, this point is 6 places higher than this. Right? The second point here is 3 places across the page. So my rise over my run is 6 over 3, but it is a negative gradient. So it's negative 6 over 3, simplified to negative 2. Right, let's look at doing one from scratch. Here I have a grid with a line on it. So let's look at what the steps were. Firstly, from any 2 points, draw a right-angled triangle. Well, I don't have any 2 points yet, so I need to place them on. So what I need to look at the grid lines to see where there is some point on the grid lines where the line intersects. So here I have one here. I'm looking for a second point. I might just take this one down here. So I know the exact locations of those points. So this one down on the bottom here is located 1, negative 1, and this point up here is exactly 3, 3. Now the second thing is I need to draw that right angled triangle. So I do need to draw my line across the page, draw my line up, and so that the line of hypotenuse is actually the original line. Now I need to do a bit of counting. So down the bottom here I've moved across 2 positions. So those 2 points are 2 positions on the x-axis across. And I have a rise of 4. I also know that this graph is heading up in a positive direction. So now I can write the gradient. Rise over the run will equal positive 4 over 2. Well, there's a better way of writing 4 over 2. Positive 2. So that's my gradient. Alright, lastly, what about if I haven't got the line? What about if I actually just get given 2 points? And from those 2 points, I want to find the gradient. Well, obviously the easiest way would probably be to sketch it or to draw it on a graph. So on the right hand side here, I have a graph already drawn. I have the 2 points and I can do my counting across the page and up. However, you may not be allowed to, or you may be not practical to draw a sketch. So one of the easiest ways to do it is to actually take those numbers and put them into a table. So the first one, negative 3, 1. Second coordinate, 4, 6. And what I can do is I can see that it's going across the page 7 places. So that's that red line. that red line has gone from the point on the left to the point up on the right. It's gone across 7 places. This bottom number here is 5. It's actually gone up 5 places. So the bottom number here is actually giving me an indication of the rise, and the top number is giving me an indication of the run. Alright, so now that I have my rise and my run, I can actually work out the gradient. Now the difficult here is the rise is the y coordinates, so that's going to be 5, and my run, which is the x coordinates across the x-axis, is a 7. So the gradient here is 5/7. So let's look at doing one from scratch. Let's just pick 2 points. Let's take -2, 0, and 4, 6. If I want to draw a little table of values, I can go across the page, or I can go down, but I'm going to go across for now. Put in my values, -2, 0, 4, 6. This number here has gone across, because x is the x-axis going across. It's gone across 6 places. And this one here is the y, gives me an idea of height, has gone up 6 places. So my rise over my run will be 6. So there's my rise down the bottom, right, and my run will also be 6. The answer will be 1. Now it doesn't matter if you do it in an opposite order. I'll do a table going down the page for the moment. If I had them in a different order and had started as 4, 6 and -2, 0, the difference between the rise is -6. This number here, -6. So remember, the y axis is the rise. It goes up and down the page. So it would be -6 over -6, which still comes out to be 1. It's just you end up with 2 negatives in the calculation. Well, let's see if we do it a different way. There is a fancy little way to do it where you do not have to draw a sketch, where you do not have to do a table. So we'll look at how that works. So what it is, we'll start with the same 2 points, -2, 0 and 4, 6. And what it is, it's a formula. The formula goes along the lines of y2 minus y1 over x2 minus x1. So what it is, we have x1, y1, x2, y2, and you just put those numbers into the formula. So it will be second y value is 6, take away the first y value of 0, the second x value of 4, take away the first x value of -2, and the answer will be 6/6, which equals a gradient of 1. Works quite well, particularly if you set them up to begin with. The only difficulty is sometimes it gets a little bit confusing if you don't label x1 and y1, and you might get them a little bit muddled up. But it's the same process. Right, good luck with your exercises. Don't forget to bring a question to class, and make sure that your notes are kept accurate.